Right, so we're going to have a wee look at an introduction or a recap for orthographics. So regardless of what level you're studying at, orthographics will be a main part of your course. Orthographics allow us to convey information about a 3D object with enough detail to allow accurate manufacture. So to start off with, what I have down here is my title box. Now, just like in an essay, the title shouldn't be taking up too much of the room. It's not too much of the page rather. It's not the dominant item on the page. It's just a small section of the page that allows us to put the vital information in to identify what this drawing is. So a title box could be a long, thin strip down the bottom. You may also just see it as a rectangle hidden somewhere in a corner of the page. For National 5 and higher, you could be asked for information that could be included in the title box. So name, the name of the designer or the draftsperson who has done the drawing. Date is very important. We always want to make sure we are using the most recent drawings in case there has been any updates or edits. Title, what is it you're actually drawing? The drawing number, particularly when you are looking at something, for example, a building, there will be different sets of drawings at different scales containing different information, different layers. So this will indicate what order the drawings will go in, or to refer to, see drawing number 6, for example. Scale, if we're including scale, that is for every item on the page unless otherwise stated, as we'll find out later on. And for higher, you will be also expected to know about tolerances, which we will cover in our standards and conventions lesson. In this corner here, we have a very crudely drawn out third angle projection symbol. Now for National 5 and higher, you will only encounter third angle projection. There are 4, but we only need to worry about the third one. All this is telling us is it's telling us how the drawing has been laid out. So for example, if I was to bring in an object here, this symbol tells me that if there is a drawing that appears to the right hand side, I am looking at it from the right. If there is a drawing that appears to the left hand side, I am looking at it from the left. And if there is a drawing that appears at the top, I'm looking at it from above. Okay. Now, one of the things that is very confusing to get started off with is how do we lay the drawings out? The drawings are always laid out in the same order. Elevation is the most important one, and that is looking at it straight on. So if you imagine you're having a conversation with someone, you're always talking to them straight on. That will go in the middle of the page here at the bottom. And that allows the plan, i.e. the top view, to go to the top. The end elevation from the right can go to the right, and the end elevation from the left can go on the left. But what is an elevation? Now, if I was drawing my phone, it makes sense that I would have this as my elevation in this particular orientation. But if I just take the phone out of this for a moment, let's think about another object. So here we have a Sharpie pen. What is the correct orientation for the pen? Is it this way? Is it this way? What about this way? There is no correct orientation for some items. For some items, we are used to seeing them in a particular orientation, like our phone. But for some items, they can be laid out in any particular format. All that is important at this stage is once you have chosen your elevation, that these views that are projected out from it match. So if I was to draw this eraser as my elevation this way, I would expect my plan, my end elevation, my end elevation. If, however, I decided to draw it this way, I would expect my plan, my end elevation, my end elevation. So what we're going to do just now is we're going to look at this pictorial that I have included. We have a cuboid shape, which has had a chamfer applied to it, i.e. a 45-degree cut has been applied to the corner. And we also have a cylinder or a circular hole, which we're not too sure of the depth. Okay, so from this drawing, I have enough information to produce an orthographic sketch for all of my views. For this video, I am going to assume that this direction here is my elevation. So this is going to be my front. So this blue section is what I'm going to draw as the elevation. So the elevation in this case, let me just check. I'm going to use a ruler here, just for a straight edge. I'm not doing any measurements. I'm going to draw my elevation in the centre of the page, roughly at the bottom. Okay, now I'm leaving myself a distance here because one of the things that defines our British standards for our view types or our view names is they always go underneath the drawing. Okay, so as we start to learn about British standards or conventions, these are a series of rules that must be followed. So for this view here, underneath it, I am going to label that as my elevation. Okay, so another British standard that we're learning about just now is our line types. I have used a very light line as a construction line. So this is a continuous thin line which can be used to build up the drawing, i.e. construct it, or later on I will use it to project the sizes into the other views. So still using the light line, I'm going to apply my chamfer, and that is me pretty happy with how I've laid out that drawing. Because I am happy with it, I am now going to use my second line type, which is the outline. An outline is a continuous thick line. It dictates or details any visible edge. So as I continue this around here just now, making sure that my corners are nice and sharp. I'm not overshooting them, but I am making sure that they meet. We will not cover dimensioning in this video. We are purely looking at the sketch just now. Now I'm having to use quite a heavy pencil just now. As you can see, it's starting to smudge, but that is just unfortunately what I have to hand in these times. So my elevation, the blue section, perfect. We know exactly what we can see here. So that's the elevation. If I draw it on the right hand side, I have to imagine that this is me looking at my elevation. I am coming round to the right and I'm looking at this end straight on. So the word orthographic. Ortho means straight. If you think about an orthodontist, they make your teeth straight. So using this information, if I'm looking at it straight on, in my mind's eye, I can imagine that this is going to be a rectangle. This rectangle that I can't see is the same height as this blue section for our elevation. So what I can do is, using the continuous thin line again, is I can project these sizes across. Yep. I haven't got any dimensions to this, so I'm doing it on proportion. I'm looking at the thickness of it, and I'm going to draw in my end elevation with my construction lines. Okay, I'm pretty happy with that. So again, what I'm going to do just now is I'm going to now put in the label for this view, which is your end elevation. Okay. So now that the drawing is complete and I'm happy with it, I will again, using my outline, continuous thick, I will outline the information or the visible edges, that what I can see. And just make sure that that is all tidied up there. Okay, back in the good old days of using drawing boards, there was a technique where you would be using a 45-degree set square. You would be putting this in and creating a direction changer or a bounce line. Because we're doing an orthographic sketch, that is no longer required. There are two ways to produce the plan. One, you can gauge it by eye, or two, you can use your trammel method. But what is really important is that the thickness of this purple area is the same size as this end elevation. So this thickness here is the same thickness of our plan. Okay, if I was to take my fingers up, I would hit a direction changer or a bounce line and come across. Because this is a sketch, that tends not to happen anymore. It worked better with the drawing boards. As long as your sketch is in proportion for National 5 and higher, you will be fine. So what I'm doing just now is I've drawn this back line, and then, as I said, using roughly the same sort of dimensions here, you're going to take that across. Now, this is where the drawing starts to become slightly more complex. In the plan view, which is floating above the object, we can see the purple section and the yellow section. We're ignoring the whole for now. We'll come back and do our hidden information. We're just seeing what is visible at the moment. With the yellow and the purple, if I was above it, they will both appear as two flat rectangles. However, at the moment, if I was to outline the visible edges that I can see, I do not have a purple or a yellow section. I have one continuous rectangle. So where would I finish if I was to apply colour to this? Where would the yellow finish and where would the purple finish? And it's about looking at this pictorial again and seeing the relationships between the two sides. The dot here represents the change between the yellow chamfer and the purple flat face. It's here on the elevation. By using the continuous thin projection line, I can take that corner up and I now have a yellow rectangle and a purple rectangle. Two surfaces. So that's my plan, elevation, end elevation. Looking at it from the other side, again, if we were using the drawing boards, we'd be doing our 45, but because it's a sketch, again, as long as it's in proportion, any horizontal line here, I'm going to take across. Again, thinking about this thickness, I want it to be the same. So as I said, if you were doing this in the old style, you would be putting in a 45-degree direction changer. You would be bringing this line over till it hits the direction changer. Funnily enough, it then changes direction. You would then be bringing this line over till it hits the direction changer, and you can bring it down. When you're using the drawing board, that is the most accurate way of transferring the sizes over. It's also the quickest, as it saves you having to measure everything twice. The thing is though, if you do not get this as exactly as a 45-degree angle, it will skew your drawing and make it either thicker or thinner. So it's always best just to check your proportions. So as I said, this is the view from the left-hand side. It's also called an end elevation. However, if we look at the pictorial, the end elevation from the left-hand side and the end elevation from the right-hand side have to be different. Here we had a nice flat rectangle. Here we have the reddish brown section, and again we can just see that yellow chamfer. If I look at my end elevation, I cannot see this line. It's not been drawn. To find out where that line is, we then look at that corner. We're going to project that across. So here, once you get used to it, you can skip the construction line and just commit straight to that outline. If we were pursuing the National 4 qualification, this would be approximately the amount of information that we'd be looking for. For National 5 and higher, we need to start thinking about our hidden detail, particularly of the circle and of this edge. So we've already been introduced to the construction continuous thin line. We've been introduced to the continuous thick outline. We're now going to look at hidden detail. Now, hidden detail is essentially X-ray vision. So on this shape, we know that there is a circle and there's a hole in here, but we don't know how far down it goes. So for example, if I was to sketch in here and I used a dashed line and said that the hole only came this far down, it was a blind hole, i.e. it doesn't go all the way through, you would be able to understand what I mean by that. It's the same that's been applied here. It's the same if I was also to apply the hidden detail for the back corner. Imagining it's always like it's a see-through section, we would be able to apply that hidden detail to give the impression of an X-ray. Same here. So, if I was standing on this end elevation, I see the brown, I see the yellow. If I'm round here, it's flat, but behind that is this edge, which is important. To represent that on the orthographic, I would be taking that corner over, and I would then be applying a dashed thin line of even dashes to represent the edge. The edge should meet the dashes. Okay, you shouldn't end on a gap, you should meet on the dashes. So this dashed line means that if I was standing here, I cannot see this edge, it's happening behind it. So let's take the same process and apply that to our circle. So I'm going to apply on the plan, I'm going to draw a circle and I'm going to put it about there. Now, do I have a circle template? I do not. So, here we go. We're going to cheat today, just so that this is clear of what we're doing. So there we go. Nice queen's head. If this was a sketch, guys, I would be marked down for this, but I want this to be as clear as I can. So I have got got my circle. I'm going to rub out these construction lines just now. This circle needs to therefore be represented as a whole. We can see here it comes all the way down and then there's a bit left. So this hole needs to come down, and I'll say it's maybe going to stop about there. But how wide is the circle? So this is where we need to find the centre of our circle. And I'm going to put the centre of my circle there. Now I can't leave the lines as thin lines because that means it's a projection or a construction line. I can't do it as a solid line, it would mean that I can see it, and I can't do it as a dashed line or it means it's hidden detail. So for circles, what we do is we do a long and a dot and a long. Now look at the placement of my long lines. The two long lines cross in the exact centre. There is a dot and then the long line breaks through the circle. And it breaks through the circle to point out the fact that it is imaginary. Where this centre line breaks the circle is the biggest or largest part of the circle, and I can project that line down. And again on this side I can project it down. Here was the depth that I said the hole was going to go to, and so therefore with my hidden detail line I can then create a series of thin dashes . So it goes to there. And they go over. The dashes again should go around the corners, so you should have defined areas here where it crosses the outline and where it becomes a circle. Now because again this is 2D, it's not rendered and we can't see that this is a cylinder, there's no reason that I would assume that that is a circle. That could quite easily be a rectangular hole. If that bit wasn't there, this could easily be a square or rectangular hole. And for that reason we therefore take our centre line and we will draw it down the centre of that circular hole. So as you can see, this centre line projects outside of the shape. Long, short, or long dot, both are acceptable. So if I've shown the hole on this view, I would also see it on both of my end elevation and left and right. So what we'll do is we'll do it the old-fashioned way first. We find out where the circle breaks the centre line. We would take that across to the direction changer and we would bring that down. Take it to where it meets the direction changer and then we bring it down. And by transferring the sizes that way across, we're able to see where the hole would be. So again, using the thin dashed, and then we can put our centre line down through it as well. So long, dot, long, dot, long. And that's me now saying there is a circular hole in that object. So this end elevation is complete, this elevation is complete, and this plan is complete. The only thing that's finished now is I need to show the circular hole on this side as well. Now this time on the opposite side I'd obviously use the direction changer. If you're not using the direction changer, you have to estimate it. We'd be looking at, I've drawn it a wee bit closer to this edge than that edge. So again, looking at the proportions, guessing, and then taking it across. Taking that across as well. So the rules that we need to follow for this style of drawing is 1. The views must always be laid out thus. Elevation is directly below the plan. End elevation is always in line with the elevation. Generally you will only be given 3 orthographic views. If it's something that's cylindrical or symmetrical, you may only be given 2 views. Just until we get the practice, I have laid out all 4 views. As you start to improve and uncover other drawings, these may be replaced with sectional end elevations. There are 4 line types that we need to learn for National 5 in this drawing, and as we move on there'll be additional ones. We have the light continuous thin for construction and projection. We have the continuous thick for outlines and visible edges. We have the dashed thin for hidden detail. and we have got the centre lines, which are long, short, which is referred to as a chain, and they obviously cross for a circle. We have introduced ourselves to the idea of the title box and the various pieces of information required for National 5 and higher, and a really ropey third angle projection symbol. If they've got any questions, guys, please send me a message.